Hello all. In this video we're going to be evaluating this integral. This integral is going to require some substitution. It's not an extremely straightforward substitution. If you're clever you can make it in a single use substitution, but we're going to take a pair of them because that's the most natural way to solve this, or at least I think so. So anyway, let's go ahead and take a look at this. So remember, when we're looking to do a substitution, we're looking for pieces of the problem where the derivative is present, where if we divide out by the derivative it's going to make the problem easier. And we noticed a couple of things. First of all, we see this tangent of e to the x, and if we divide out by the derivative of tangent, we know that's going to be secant squared, and that's a good thing to see, but this e to the x makes things a little bit muddy. Now, the best thing to do would be let u be equal to tangent of e to the x, and that's going to be the very best substitution that you could choose in this case. But in our case, let's assume that we don't see that immediately, and we're still a little bit confused by this e to the x. One thing we might be able to see here is that e to the x is definitely an inside function in terms of a composition of functions, and as such is probably a pretty good choice for a u substitution. So let's start there. So let's go ahead and let u be equal to e to the x. This means that du dx is going to be equal to e to the x, which means that du all over e to the x is going to be equal to dx. So there we go. We've got the first part of our substitution put together. Well, let's go ahead and figure out how that impacts the integral. So this is going to be a secant squared of, and instead of e to the x, we're going to replace this with u. This e to the x that's attached to the secant squared, we could either leave it as e to the x or replace it with u. I'm going to leave it as e to the x, and I'm going to count on the fact that the e to the x beneath my du is going to take care of it. So this is just going to stay as e to the x right here. The dx is turning into du divided by e to the x. All of that is going to be over tangent of, it would be e to the x normally, but I'm going to change that to u so that I have that variable there. Okay, so the e to the x's are going to cancel, and this is just leaving us with the integral of secant squared of u all over tangent of u. So we're taking a look at this and realizing, you know what, we could solve this with another substitution. The derivative of tangent is secant squared. And so if we choose tangent as to be a new variable of substitution, we're going to end up dividing out by that secant squared, and this is going to be a much easier problem. So let's go ahead and do that. We've already got one variable here that we've done. Let's go ahead and make a new variable v, and we're going to let v be tangent of u. Right? So we let v be tangent of u, that means that dv du is going to be equal to secant squared of u, which means that dv divided by secant squared of u is going to be equal to du. And we'll go ahead and we'll make those substitutions here. So we make the substitutions. The secant squared, we'll just leave it right here. We are content that it's going to be taken care of by the replacement of du here. And tangent of u is just going to turn into v, and this is going to end up being dv divided by secant squared of u. The secant squareds are going to cancel, and we're left with just the integral of 1 over v dv. That's a v. In fact, let's go ahead and fix that. Okay. This is an easy integral for us to do. We know the antiderivative of 1 over v, it's natural log of absolute value of v. After that, we can just start replacing the variables again. So this is natural log of absolute value of tangent of u. And u, of course, gets replaced, and this becomes natural log of the absolute value of tangent of e to the x. And that's all we need. So, hopefully this makes sense. This is a little bit more complicated a substitution than we usually do. Again, You would not have to go through this double variable substitution process if you had realized that in the very beginning you could let u be equal to tangent of e to the x. Because the derivative of tangent of e to the x, it requires a chain rule, but the derivative of tangent of e to the x is secant squared e to the x times e to the x. And this whole numerator would be canceled out when you did the u substitution. So if you see that right off the bat, great. But if you don't, it's not a problem. Just go ahead and start trying substitutions. You can eventually find your way through. If you have any questions on this sort of thing, go ahead and ask questions in class or stop by my office. But as always, good luck and happy mathing.